All right, good morning, nerds. Today is part 4 of our Unity first-person shooter tutorials. Today's goal is going to be to get the enemy to respond to damage and then potentially die. And while we're at it, we're going to go ahead and add the HP bar. If you're in one of my classes, we probably did that step more towards the end, but in this case, we're going to go ahead and do it here just because it's a relatively quick thing. And the enemy taking damage step is also pretty quick. So we're just going to merge two fairly fast concepts into one. So what we're going to need for this is, as with the previous couple of tutorials, it's going to require that you've done the previous ones because we're going to be relying on the player bullet code that we wrote last time. So as you may remember from the last installment of this, what we did last time was we got the player bullet firing. And if we get closer to the enemy, we can see that the bullets do indeed hit the enemy and they despawn, but they are not actually, or the bullets are terminating, but the enemy is not reacting in any way to that damage. So today's goal is going to be to fix that. We're also going to have the enemy not react to the damage that we're seeing. For instance, right now you can see that the enemy has taken a hit here and is drifting along that wall as a result of having been shot by the bullets. And he shouldn't be doing that. So we're going to go ahead and fix that problem as well. So the very first thing that we're going to do is we're going to go ahead and stop our game. We're going to go into our enemy and we need to add an enemy script. And this is another case. I called this out once before when we were working on player. But there's a few different philosophies in Unity scripting, and some of them involve a lot of little tiny scripts, and there would be some advantage to having hit point and damage scripts on a separate script, because then I could utilize the same script for the player and the enemy, and then there are some advantages with kind of doing an all-encompassing one. And honestly, my take is, I feel the best of both worlds is big superscripts, but also doing some inheritance to mean that I don't have to replicate some of that. Inheritance is out of the scope of this tutorial series, so we're not going to mess with that. But this is not necessarily how I would code this in the wild, but it will work. So my first step is going to be going back into my prefabs folder, selecting my enemy prefab, and just like what we've done with a couple of the other things is, I don't necessarily need to actually open my prefab for this, just being in this screen is good enough. I want to go to my add component menu here, or button rather, not menu. I'm going to go to my add component button, and because the enemy script does not exist yet, we need to go ahead and add one. So I'm going to add enemy script, and then use create and add, and it should show up here any moment. It's trying, and we can double click on that to load up Visual Studio. It should load anytime, I promise. There it goes. All right, so in our enemy, we have kind of the same layout that we have with some other things. If we go to enemy script, you can see we've got some usings up there, we've got a public class, we've got start and update. And just like what we did with player, where we set up some variables, we're gonna do the exact same thing with the enemy. So in our enemy script, the variables that we're going to add for right now, the only one that we really care about for the moment is 3 variables. We're going to do public int HP max. And for now, we're going to set that to 100. We're going to give him 100 hit points because I'm visualizing in my head that the hit points for the enemy are percentage based. So bullets will take a percentage of your health. You definitely wouldn't have to do this. I mean, the number itself is arbitrary. I could do 37 hit points if I wanted to. It just involves like which math do I want to do. Then the next one, and this is going to be a somewhat curious decision, is going to be public int HP. And I'm not going to set a value at all. Now, that will default it to a value of 0, but I want to point out that in the inspector, I can set these values, and so inspector value set in Unity will override these. Now, my goal here is that HP actually stays 0. I don't want a user to actually change that value. And the reason is we want to minimize accidental damage, and we want to do what I like to refer to as idiot prevention. But basically, we're kind of mistake proofing our game as much as we can. In this case, by specifying an HP damage, and if I save this, and you don't have to follow along with this part, but if I save this and I look at enemy, I now have two different boxes where I would potentially have to enter data. And what happens if a user changes HP max but doesn't change the other one, or they change HP or don't change the other one? It's going to cause some weird behavior. So what we're going to do instead is we're going to leave HP at 0 and HP max at 100, and that's going to kind of indicate, hopefully the hint to the user will be that you really should only be changing HP max, and HP will somehow work itself out. And we're going to go ahead and code that in first. So the way HP is going to work itself out is in our start, which again is called on the very first frame and never, or before the first frame, and never again. What we're going to do is just say HP equals HP max. That will automatically set me to full health at the beginning, regardless of whether that HP max variable has been changed, updated, set different. If they match, if they don't match, it's just going to fix it no matter what. So this is going to give us a good spot to start from. The remainder of our code is actually pretty simple. We've already dealt with a lot of the complexities of shooting in the actual bullet script. So really all we need to do in the enemy script is actually react to hits. So in this case, what we're going to do is we're going to look at collision. And that involves adding in one of Unity's built-in functions. We did this exact same thing, as you might recall, in the bullet script. We said, hey, on collision enter, if you hit anything, we want to go ahead and destroy ourselves. We're going to do something very, very similar with the enemy. But it's going to be a little bit more nuanced, a little bit more refined. We don't want the enemy suiciding if he just like smacks into a wall or something. So we're going to make it a little bit more refined than that. Also, that would let you, as the player, you could just potentially win the game by just charging and touching all the enemies. And we don't really want that. We want that collision to be a little bit more specific. So on the enemy side, again, just like last time, we're going to go after void update is completed. So after this closing curly brace, but still inside the class. And we're going to add in a new function. We're going to add in the Unity built-in on collision enter function. And again, like last time, we're going to let autotype do its job. So I'm going to start typing on collision enter and hit tab to fill it all in. Because I don't want to have to memorize that whole mess. So we've got collision is already in our parameters. It is a private void. That's just fine. There's no reason for us to want to access it from outside. This is a pretty good setup. Now, when we collide with something, the nice thing is that collision is going to be saved in the other thing's collision is going to be saved in this collision variable, which is super helpful for us because then we can take a look at that data. So what we're going to do here is we're going to start with a very, very simple if statement. And this is really not a very complicated system here. So, and that's why this tutorial is going to be a little shorter than some. If we do our if statements, we're going to do if, and now we need to know what hit us. And if you recall correctly, when we set up our bullet in our prefab screen, you'll remember that we set up the tag of bullet, which means that we can look at the object's tag to see what we hit. So we're going to look, and unfortunately we can't get to the tag of the collision object by itself. I'm trying to type in tag and it's not popping up with any matches. But what we can do is we can get collision's game object. So that's the game object that's attached to the collider that we're colliding with. In this case, hopefully the bullet. And we can get its tag. And we can do an equals comparison to see if that tag matches bullet. This is case sensitive, so please make sure that your capitalization is the same. And rather than being the same as mine, the thing that you need to ensure is that it's the same as the tag. So my tag is a capital B. That means that my equals needs to be a capital B as well. Once I've got that in, that means that if this is true, then I have been hit by a bullet and I need to do something. And that something is, of course, taking damage. But we don't want to do this statically. And static damage would be like, for example, if I touch a bullet, I always take 5 damage or something like that. Because again, we want to think ahead towards what if guns change, what if the value of bullet changes, whatever. But as you recall, we did set up that when bullets fire, they actually have a damage value. So we need to get to that. So what we're going to do here is we're going to call the take damage function, which will green or will redline because we haven't written this yet, but we are going to in just a moment. So for now, live with the fact that this will generate an error, but I promise within the next couple of minutes, we're going to go ahead and fix that. And the value we're going to pass into our damage function is going to be the bullet's damage. Now, how much is that? We don't really know, but what we do know is that the bullet has a bullet script. And if it has a bullet script has a public damage variable, so we can actually see that variable. We just have to find it. And this is going to be a little bit longer than some of the other pieces of code, but it's really pretty straightforward. We're going to use a very, very similar system. We're going to say, hey, collision, what game object are you? And that game object has a component. So we're going to use the getComponent function, which I think we used in a previous thing. Yeah, we used it once before when we were trying to get the bullet script to initialize the bullet. We're going to basically follow this exact same pattern that we did in the player script in our enemy script. So we're going to do collision.gameObject. That is the game object that represents our bullet. We're going to go getComponent, angle brackets to hit its bullet script. And that is a function, so it needs the double parentheses. And now we can actually pull the damage value out of that script. So what we're doing is we're saying get the damage value that's in the bullet script, that's in the game object, that's in the collider that would just hit us. And give that damage to the take damage function that we are about to write. Okay, because in programming, sometimes it makes the most sense to just kind of work backwards and get our explanations that way. So it's the damage that's in the bullet script, that's in the game object, that just hit us with our collision. Okay, that is actually it for this function for now. It does not all functions need to be difficult. 3 lines and we're done. The next function that we're going to write, this one's a little bit longer, but honestly pretty simple, is going to be public void take damage. We're not asking this function to return us any data. We're just asking it to do something. So void works out just fine. We will have some functions later that we need to request data, but for now this is going to be good. And of course, if we're going to take damage, we need to know how much damage we just took. So we're going to ask for an integer value that represents the amount of damage we want to subtract. The equation for this is relatively easy. We're going to use the minus equals system to subtract some from our HP. So we're going to say, hey, HP, subtract damage. And so we'll use the minus equals to generate that. And this is going to change our HP to be our old HP minus the damage value. That's about it for that part. Now, the challenge that we're going to have here is there's a few things that could potentially happen. Potentially, we may still have positive hit points, no big deal, we don't really care about that. But also potentially, there's 2 other possibilities that are in what we would call our outliers. And the outliers would be, possibly I go below 0. And if I go below 0 or equal to 0, what I want to do is go ahead and die. So we're going to do if HP is less than or equal to 0. In that event, what we're going to do is just like we did with the bullet, we're going to destroy our own game object, which will destroy the enemy. So we're going to go destroy game object, and there we go. The enemy will self-terminate. The other thing, though, the other possibility is later on we may implement something like health pickups that do some healing. In that case, the other possible outlier, maybe it heals us to within a range, and that's great, but it's possible that it heals us for more hit points than we have, or than we should have. And for this game, we're not going to allow overhealing at this point in time. At some point, we may decide to change that. But for now, we're not going to allow overhealing. So we're going to say if HP is greater than HP max, if that happens, we're just going to say HP equals HP max. So if you go over, just set it to the maximum. And that's a pretty easy line of code. We could do some things with math.max or math.min if you're familiar with those functions, but in this case, that's more processor intensive than what we're doing here, and so it's just easier to deal with things the way that we've got them. All right, so that's really it for taking damage. Now, remember that we said on our player that the bullet is going to do 100 points of damage, so we should be able to one-shot kill the enemy at this point. So I'm going to do a file save all. And we're going to go ahead and test that and just see if we can kill the enemy. If we can, then I also want to drop the damage down a little bit to something maybe a little bit tamer, so that way we can verify what happens if we hit it with a smaller value. So, whoops, I clicked on the wrong thing there. Okay, let's try this again. So I'm going to go ahead and shoot a bullet that hit the enemy, and sure enough, it did wipe him out. So that's perfect. But now what I'm going to do is I'm going to reset. I'm going to go into my player values and, oh, I need to probably create a variable for that. Oh, we decided not to on purpose. That's right. So I'm going to go into my player script, and right here on what is line 49 for me, but this is the line where we go to that get component, we do our initialization of our bullets. So this is almost the very, very bottom of player script. In there, I'm going to go ahead and change my 100. I'm going to change that to 20. 20 ought to give me 5 shots to kill the enemy. That feels better for now. I may want to change that again later, but for now, this is good. Then I'm going to go back in. I saved. We're going to go back in and play the game. And again, I'm going to fire a couple bullets. That was about 4, 5. Okay, maybe I miscounted, but it did kill him after about 5 bullets. So I'm not sure if that was completely accurate or not, but that felt pretty good. And just because I like to test accurately, let's go ahead and fire when we can actually count. So I'm going to get nice and close. 1. Whoops, I keep on hitting the play button with my mouse instead of hitting. Let's try this one more time. So we're going to line up. We're going to go 1, 2, 3, 4, waiting for a second to make sure that didn't kill him. 5, and that did kill him. So apparently that was just miscounting on my part last time. So that's good. All right, so now we feel good about that. The next thing that we're going to do is we're going to go ahead and create HP bars. And there's a bunch of different ways we could do this. Some of them involve UI, some of them involve sprites. There's some things we can do that's called bannering that will keep the HP bar always facing us. But for now, I'm just going to keep it kind of simple and just make a block of cube above us. And it's really more about teaching the fundamental idea behind what is an HP bar than it really is about you know, that bar being the type of image or the type of graphic or whatever that we want. And since we are used to working with 3D primitives at this point, we're just going to keep on doing that rather than introducing canvas or something crazy at this point in time. So what we're going to do is we're going to go to our enemy, and again, we're going to go to our enemy prefab. And I'm going to kind of pivot him around so that I can kind of see his front here. And I'm going to create off the capsule, I'm going to create an empty or a 3D object that is going to be a cube. And that cube is going to represent my HP bar. And we're going to get a little bit crazy here, but I'm going to just, first off, I'm going to start by playing around with the scale a little bit. Really just trying to get kind of a sense of how big I want this thing to be. So I'm going to drop it like that, and that feels like a pretty decent scale. Now I'm looking at my numbers over here. I'm at 0.96, 0.97, so I'm just going to make this 0.1 and 0.1. That feels like a pretty good HP bar size to have above him. And then now I'm going to change my cursor to a W to get my directional sensor. And we're just going to kind of place that a little bit above his head by dragging up on the Y-axis. So my Y-axis is going to be, right now I have it at 1.189. Really, we want to just make sure it's a little bit above his head. The exact value doesn't matter. But we also want to guarantee that my, my X scale is 1, my X position is 0, and my Z position is 0. If you've got that and the Z forward is looking good and it lines up with your enemy's forward, you're probably in good shape. So now we need to actually make the bar, and this is going to be the inside of my bar. We're going to pull a couple little tricks here. But what I'm going to do next is I'm going to go back to my materials, and I've got a red and I've got a green. So I'm going to make the red be the take damage part, and that's going to represent the HP max bar slowly becoming more visible as the HP bar declines. So this is going to be my inside, and so I'm going to color this one red because this is going to be the damage that he's showing. So this guy is going to be red. And so now I've got my HP bar. It's looking pretty good. And now I'm going to duplicate it. So I'm going to go Control D or Apple D, depending on which computer you're on. And all I'm going to do with this one is slightly scale the Y and the Z. So I'm at 0.1. I'm going to change the Z on this new cube. I'm going to change it to, oh, and I need to, actually, I forgot, I do need to parent that to the original cube. And that really should make everything go, it should look like a zeroed out transform because it is exactly the same size and same shape as my previous bar. All we're going to do now is adjust, we need to leave the X scaling, that is very, very important. The X scale needs to be 1. But we're going to slightly adjust the Y and Z to 1.2 each. So Y is going to be 1.2 and Z is going to be 1.2. Now notice that that didn't make it much bigger. Really all this is doing is scaling at 1.2 relative to the smaller value. And as you can tell, I'm still in my school, but that's okay. So we're going to, it's relative to the smaller value. And you'll notice that that did not make that much of a change. Now what we're going to do is we're going to color this cube. We're going to make sure we've got this cube selected. We're going to grab the green player material and drag it on that cube. So now he's got a green head point bar, and you can kind of see that other one kind of creeping through on the sides, but we're going to be looking at it from mostly the front angle, and so this is going to be okay. Now what you're going to notice here is because the scale is 1, it means we're exactly as wide as our parent cube, which is also just as wide as the cylinder, or the capsule rather, so this is all looking pretty good. But the cool thing is with the inside one, we're going to take advantage of the fact that scale is relative to your parent object. So for instance, Y 1.2 is not a 1.2 in the bigger sense of the word. It's because it's comparing it to the scale of my parent, which is already 0.1, so it's already very, very small. But on the horizontal, since my scale is currently 1, it means I'm exactly as wide as my parent cube, which also means that if I were injured, let's say I'm at 50% health, if I do 0.5 here, that cube will take up half the space of the parent. And so it's gonna subtract out from the center. Now there are some ways to make this subtract out from like one side or the other, but I kind of like this center deletion. I just like how it looks, so we're gonna leave that alone. And you will notice that now we can kind of see that this cube is a little bit bigger than the other one, but we have to get really close before it's noticeable. And honestly, I still think the effect is kind of neat. So I'm gonna go ahead and leave it. I kind of like that. If you wanted less of an effect though, you could nudge this down. For instance, if you did like 1.1 or 1.05 or something small, it just has to be bigger than 1 and it'll be big enough to wrap around the outside of that other one. And you would do that again to both Y and Z equally. So now we've got this really nice HP bar adjustment. And now it's time to go ahead and make it work. So what we can do in our code is go up in the enemy script, we're going to add a game object for our HP bar. So if I go to my enemy, and I'm just double checking my other code to make sure that there wasn't anything else in there. Okay, so we're going to add, and I'm going to just break a couple lines down. I like separating out what kinds of variables I'm dealing with where. It makes it a little bit more easy to read. So I'm going to add an HP bar. So I'm going to go public game object HP bar, and I'm going to need to attach that later on in Unity to make this work, but I'm going to go ahead and save that. And now in my take damage function, when I take damage, I also want to adjust the bar. So if the HP bar is my current hit point bar, the green one, then what I can do here is adjust my scale. And unfortunately in Unity, messing with a scale directly is actually kind of a touchy operation. So what we're gonna do is we're gonna grab a new vector. So we're gonna say vector 3. We're gonna call that new scale. And we're gonna set it equal to HP bar .transform.local scale. And local scale is very important. Otherwise we'll be dealing with world scale, which is very, very different, and we don't really want that. Okay, so we're gonna do local scale. And we're gonna just modify new scale.x is gonna be equal to, and what we want is the percentage. And the nice thing is because scale can be expressed as a percentage and so can our hit point values, the math is just gonna be 1 to 1. If I have full hit points, if I have 100 out of 100, that's 1, which would be a scale of 1. If I have 0 out of 100, that would be 0, which would mean my entire bar is gone. And theoretically I would be despawned at that point, but hypothetically that would be my bar is gone. So as long as I set it equal to HP divided by HP max, I should be good to go. Okay, so I'm gonna go ahead and save this, and we do still need to make one quick edit in the inspector, but that should be pretty tame. I'm going to choose not to make that edit in the inspector just for a moment because I do want to show how this works. If I run up here, because I want to show you guys some common errors, if I run up here, hey, look at that, he's got full health, that's great. If I shoot him once, you're going to notice that I got an error in the console. And the console specific error is the variable HP bar of enemy script has not been assigned. You probably need to assign the HP bar variable of the enemy script in the inspector. So it's really telling me exactly what I've done wrong. If I go into my enemy prefab, where's my prefabs? If I go into enemy, what you'll see here, actually I do need to be inside the prefab for that. What you'll see here is down in my code, I've got an HP bar, but I have not designated what that thing is. I am going to clean up my space here a little bit. So I'm going to say HP max bar, and then I'm going to name the other one the outer one, which is inside in the nest. We're going to call that HP current bar. And once we've done that, we're going to take the HP current bar and we're going to drag that into that spot on the enemy script. So it does need to be the current bar because that's the one whose size we're going to change. The HP max bar is always going to be the full size, and that's how we're going to see it subtract. So now I should be able to walk up and shoot him once and get some damage. And that's not working. But you do notice that when I hit him 5 times, that did work. So now we have some challenges. What went wrong there? So what we're going to do is we're going to debug this. And I did this one on purpose. So I want to kind of walk through the troubleshooting process of this because I think that this is a useful lesson for you guys to learn. So what we're going to do is take a look at our code and try to figure this out. Well, the equation looks good. And if I do this with math, if I hit him once, that's 80. He should be losing 20 health. So he should go from 100 to 80. And 80 divided by 100 is 0.8. And 0.8, if I change the new scale to 0.8, we've already kind of looked at that. That works. So what happened? So what I want to do here is I want to check, I'm going to do some debug logs to try to figure out what went wrong. And debug log is going to write to my console and give me information. So we're going to try debug.log. I'm going to ask for a few things. I'm going to say debug.log HP. I'm going to ask for HP max. Whoops, I was trying to copy paste and that didn't quite go. Let's try that again. Copy and paste. I'm going to paste twice because that'll save me some time here in a second. I want to test HP max, and I also want to test HP divided by HP max. So now we're going to go ahead and save that. The results shouldn't be any different, but at least we're going to give ourselves some data. And this is a really important part of the debugging process. If you don't know what's going on, ask the computer to help you. And we ask the computer to help us by asking it to show us some data. So if I open my console, as I play my game now, if I fire the bullet, we should be getting some data. And you can see now that I've fired, The first one was HP. It sure is saying 80, and then it's giving me 100 is my HP max. And for some reason, it's saying 80 divided by 100 is 0. I'm going to fire another bullet, and I'm going to turn off the collapse mode on my console. If yours is showing with a gray box around it, you have it on. If it's not showing with a gray box, it's off. That'll at least let us see the data in order. Sometimes it's handy to collapse because you've got a lot of data. Sometimes it's better to not collapse. And after the second bullet, again, they do 20 each. I'm at 60, 100, 0. That feels like it should. I'm going, well, 60 feels like the correct number of HP. 100 feels like my HP max. 0 is still questioning, but at least I'm getting some consistency in my result. 40, 100, 0, 20, 100, 0, and 0, 100, 0, along with a death. So my HP is definitely getting decreased correctly, but there's something up with this division. And we could do a lot more debugging, but we're not gonna. I'm gonna kind of give away the answer here. The answer is, the problem is that both HP and HP max are integers. And in a computer, even though newscale.x is actually a float by virtue of the fact that it's part of a vector 3, and a vector 3 is XYZ all floats, the challenge here is that a division problem involving only integers will always result in an integer. So for instance, if I'm doing, I'm gonna just, this is not actual code and will give you an error if you leave it in there. So I'm just kind of using this as demonstration space while I talk. For instance, if I do 80 divided by 100, that should equal 0.8. More specifically, 0.8. And so one would think that if anything, if I have to convert this to a whole number, we're used to thinking in this in terms of mathematics, in which case, when we round, anything from 0.5 and above would just round up. And so we would normally think this should be 1.0, okay, or more specifically, just 1, even if we were going to keep it in integers. However, with computers, if integers divide, it does so with a method called truncation. And that basically means it's never going to figure out anything past the decimal point. And so anything past a decimal point, if it's an integer, is just simply discarded. We exit out, we cross it out, we delete it. So what's happening here is when it does this division, it's just simply deleting the decimal point and everything after it, leaving only the 0. Similarly, if I did 29.1 and again converted that into an integer, it would convert to just 29, which makes some sense. But if I did 29.9999999, which is actually a bigger number than I can even store, but even if I were to do that, which we would think, oh, that's darn close to 30, that should round to 30, right? The challenge here is again, we're just deleting everything after the decimal place, and that is still just 29. So in our case, really anything short of full hit points, if you have 100 divided by 100, that's going to be 1 and it'll show as 1. But if any hit points are lost, that bar is immediately going to be 0. So we're going to go from 100 to 0 pretty much instantaneously. And that's not really what we want. We want that partial to work, right? So what we're going to do here is we're going to ask it, for the sake of this division problem, we're going to ask it to treat one of these values, and I'm just arbitrarily picking HP max, as a float. And a float, again, is a number system that allows you to have decimal points. Now that it's a float, it should resolve correctly because HP will be divided by a float, which will equal a float. The decimals should be preserved, and then we should be able to drop that decimal into newscale.x, which is also a float, and everything should work fine. So we're going to go ahead and test that again. We're going to go ahead and play our game. Fired a single bullet. I missed. Let's try that again. I still missed. I'm not very good at my own game. And we're still getting 80, 100, 0, which I thought that should fix it. Let's Let's double check and make sure that I actually did save this, because nope, it looks like it's saved. HP max, HP bar. Oh, I made another mistake. The other thing I forgot to do, I missed a line of code. I want to get rid of this float here because I actually was demonstrating the wrong problem. So I'm going to get rid of float for a second, but I will be putting that back in just a moment. The other thing that I forgot to do was we created a new vector and we never reused it. So what we really need to do here is say HP bar dot transform dot local scale equals new scale, which will again have that X value that we put in. And now what we should see, sorry, I did set up the other thing on purpose, but that one was an accident. Okay, so, but we're gonna go ahead and embrace failure and just say oops and call that good. We're gonna go ahead and shoot, and what we should see is now the entire bar went away. And that's again because I'm doing integer division. The integer division resulted in 0, which resulted in a scale of 0. So I went from fully green to fully red in one shot, but you can see that the enemy is still alive. And we can look down here in our debug log, see 80, 100, 0, which we were expecting to happen because of that whole explanation about float math a minute ago. Now I'm going to go back in and put that float back in my division problem again. So I am doing the float of HP max. We're going to go ahead and save that. We're going to go ahead and hit play again. I'm going to fire a single bullet, and you'll notice that it just took a little bit off the edge. That was 1 shot. There's 2 shots. There's 3 shots. There's 4 shots. That bar is getting pretty tiny now, and the 5th shot goes ahead and kills him. So that's perfect. The enemy is taking damage correctly. I'm feeling pretty good about that. And so we have now successfully got the enemy taking damage, and we've gotten a little bit of juice factor in that the HP bar works correctly. And so we'll go ahead and stop there. This is a great stopping point. So that's it for this tutorial. In the next session, which will be the FPS 5, we're going to get the enemy utilizing a nav mesh and make him able to hunt the player. So that'll be our next one. So please join us next time for another adventure. In the meantime, if you enjoyed this tutorial or you found it useful, please like and subscribe. And as always, keep on creating. Have a great day, everybody.